Hello everyone, this is section 2.1, which is about limit. So from this section, we will be actually starting the real calculus stuff. Chapter one was about, basically it was about the college algebra or algebra stuff. Okay, so here, this is about limit. So let's see an idea first before I actually show how we write the limit. So first here, well, when you see this graph right here, this is a straight line, right? So let's say if I want to find the value of, okay, this is y-axis, this is x-axis, y, also I can write f of x, doesn't matter. And this function is also defined as f of x function. And f of x is equals to something. We don't need that, that's not necessary. But anyway, on this line, let's say if I want to find the value of y or the value of f of x, we want to find the value of f of x when x is, let's say, 1. So what is the value of f of x when x is 1? So that means when x is exactly 1, what is the value of f of x? So when x is 1, then I can say, when x is 1, from this I can say f of 1, right? So what is the value of f of 1 when x is 1? All right, so the value of f of 1, so from this graph, well, I can see that from this graph, if I make a horizontal line, I can see that the value of f of 1 or y is 2, because this is y-axis or f of x axis, and this is x-axis, right? So value of f of 1 is 2, right? This is exact value. When x is exactly 1, f of 1 is exactly 2. All right. Now, if you remember, I think I talked about this. I don't remember, but I talked about this in chapter 1. I was talking about the approaching things, right? So let's say if x is approaching here, if x is approaching, because this point is a 0 point, right? On x-axis, it's a 0. So when is x is approaching towards 0 from the right, so when is x is approaching towards 0 from the right, so if you are denoting something from the right, then we say plus. If something is approaching from the right, it's plus. If something is approaching from the left, it's minus on the top. All right. So in this case, when x is approaching from the right, then the y or f of x, y or f of x approaches. So y-axis on this axis, this line is never gonna touch y-axis, but it's gonna approach y-axis. All right, it's approaching y-axis, but it's never gonna touch y-axis. All right, if you zoom in, if you well, there is a program called Desmos. If you type this in the Google, you can see the graph of something like this, where if you zoom in, you will see that this line will never touch this y-axis. So that means this line is approaching towards, well, on the up, it will go towards infinity. Down, it goes towards negative infinity on y-axis. On x-axis, on right-hand side, it goes towards positive infinity. And on left-hand side, it goes towards negative infinity, right? So on y, it's going towards infinity. All right. So the limit is something like this. Well, now on this thing, well, using limit, or instead of writing this whole thing, there is a limit thing where we can write, use black again. So limit, well, for limit, I can introduce lim, which is limit. And here we said when x approaches to 0 plus or from the right. So that thing we write on the bottom of the limit, x goes to 0 plus, then the value of y or f of x is equals to infinity. So here, instead of writing this, we write it like this, all right? So here we're saying that when x approaches to 0 from the right, f of x approaches towards infinity, because y we can also write f of x, right? So yeah, this is the idea of limit, all right? So if we have, let's say, uh, the basic notation, lim of x goes to, let's say x goes to c. Let's not worry about plus minus here. Let's just say a function is approaching towards a point, then f of x is equals to L. So this means when x approaches, this is O, which is to C, y approaches, or f of x approaches. So y or f of x doesn't matter. Here f of x, because we have f of x here, so let's f of x. F of x approaches to L. All right, so this is how we, so instead of writing this whole thing, we write something like this. All right, so that's the idea of the limit. All right, so now let's see, okay, let's see something like this. Okay, let's say 1, 2, let's make this a straight line, this one. Okay, this is 2. All right, 1, 2, x-axis, y-axis. All right, let's make a graph something like this. Let's say this is open circle. That means we are not including this point, and something like this, something like a parabola, but we are not including this point, which is 2. All right. So now here we need to, let's say we need to find the limit of x goes to 0. All right. So this is, let's say, f of x function. F of x function. So what is f of x approaching when x goes to 0? All right. So there is nothing plus minus on the top. So there is nothing plus minus on the top. So the only time this exists when both lim of x goes to 0 from the right of f of x is equals to lim of x goes to goes to 0 from the left. Both of this is equals to some number. So basically we're trying to say that if both of these exist and has a same limit, then this one exists and also this one converges to L. All right. So the only time we can find graph something like this, with this kind of graph, we can say that, okay, this graph, the limit of f of x when x approaches to 0 exist if both of these from the right and from the left exist with the same limit. So let's see here. So the first one, when we say the limit of x goes to, so on x-axis, again, let's say it goes to, if you just look at the x-axis, on the x-axis, it's approaching towards 0, right? And on the from the right, it's plus. So if it is 0 plus of f of x, then it's the y value is 2, right? Because if this one is approaching towards 0 on x, then y is approaching, if you can see, it's approaching towards 2, right? Similarly, same thing from the left, x goes to 0. Now from the left, and f of x goes to, again, from the left, when x is approaching from the left towards 0, y is again 2. So now both of these exist, right? Because we have a limit, a numbered limit, that means it exists. So that means if I want to find the limit of just 0, which means the limit of x goes to just 0 of f of x, it should be 2. All right. So when you can say this, you can say this. Or if you have this, you can say this. It goes both ways. All right. So if you have this, you can say this. If you have this, you can say this. All right. Okay. So let me import something from here. Let's see. Okay, right here. Okay, so let's look at this. Where is it? Let's look at this. Actually, I was trying to import something else. Okay, let's look at import desktop. Okay, let's look at this. Okay, now let's look at, okay, let's start from here. Okay, so here, when you set this graph right here, now the first one we are trying to find is the limit of, so let's say all of this is f of x function. And well, here we have a discontinuity, but anyway, so here what we're trying to find is what is f of x, or where f of x is approaching when x goes to -1. So -1 is right here. So since there is a discontinuity, which means whatever I did, I guess. So the only time I say this thing exists is when limit of x goes to -1 from the right and limit of x goes to -1 from the left has of f of x, of course, of f of x, both has same value, right? If both has same value and both of these exist, then we can say this exists. But the thing is here, when we say from the right, limit of x approaches to -1, sorry, no, this one is, let's back up. Well, this is true, but with the -1, sorry, I was thinking about this. With the -1, well, this graph ends right here. Ends right here, right? So in this case, we don't have to look at the right and left. It's just that the graph ends at -1. So when x approaches to -1, when x approaches to -1, what is f of x? The f of x is 2, so that means it's 2. All right. Well, we still need this for positive one. Sorry, this should be for positive one. Okay. And when x approaches to 0, so we have to look from the right and from the left. When x approaches to 0 from the right, it's still this point. When x approaches to 0 and from the left, it's still this point. So here is 0, because y is also 0, right? This on y-axis this is also 0. Similarly, for this one, now, so for this one is slightly different, because when x approaches to 1, so that means we have to look at when x approaches to 1 from the left, sorry, from the right, and when x approaches to 1 from the left, it's different, because this is the graph. When x approaches to 1 from the right, the f of x here is 2, right? And when x approaches from the left to 1, f of x is 1. So we have 2 different values, right? So in this case, that's why this is undefined. All right. Now for 3, it's different, because for 3, when x approaches to 3 from the left, when x approaches to 3, the x approaching to the 3 from the left and x approaching to 3 from the right, both of these approaches to the same point, right? So that's why when x approaches to 3, f of x is also, y is, or f of x is also 3. All right. Okay, now what about this one right here? As we know that the open circle means we are not including that point, and closed circle means we are including that point, right? Okay, anyway, so here, let's find the value of f of x when x approaches to 1. There is a plus on the top, so from the right. So when x approaches to 1, from the right, that means the y, or f of x, is approaching towards 2. So this is 2. And from the left, when x approaches to 1 from the left, there's a minus on the top. Then this line is approaching towards 1. So this is 1. Oops. It's 1, right? So what about a limit of x approaches to just 1? Since now both of For this one, we'll have to look at both right and left. So here, from the right is 2, from the left is it's 1. So we have two different number. So that's why it is undefined, right? And similarly for this one, when x approaches to 3, doesn't matter, it's from the left and right. When x approaches towards 3, here, we have, just a moment. Right, so here again, 3, it's gonna approach towards a same point, right? So it's from the left and from the right, it's gonna approach towards the same point. So that's why it's 1, because this is 1, all right? Okay, so the next one here, we have we have these 7 properties. All right, so the properties here, well, if you have, let's say, the limit of x approaches to c of f of x is this limit L, and for this one it's M. And when we take there is a single limit with 2 different functions, then we can split this into 2 different functions. First one, I can say L, second one, I can say M. Similarly, it's same thing for minus. And here, let's say the K is constant. Constant means some number. Then I can just pull out that and just take the limit of this inside f of x. So yeah, basically it's a very common thing where I can say, okay, even for this multiplication, I can take 2 different limit. So limit of f of x times limit of g of x. So limit of f of x is L, limit of g of x is M. All right. So here, same thing for a quotient. Same thing for power rules. I can just take the limit of this inside part and the power n is still gonna stay. Same thing for square root. I can just take the limit of this inside, which is L, right? The limit of f of x is L, and this square root is still gonna stay there. Let me do an example here. That will give you a clear idea what I'm talking about. I think, okay, let's do this one. Okay, here. Okay, so here we need to find the limit of this function when x approaches to 2. All right, like I said, the only time we can say x approaches to 2 is if we say x approaches to 2 from the right and x approaches to 2 from the left. Both of these are same, but we don't have to do that for this one. If it is a polynomial, if we have a function f of x is polynomial, then I can directly say that f of x of whatever, let's just see, f of x is equals to f of c. All right, so here, what can I say is I can directly plug in this x or this 2 value here. So we are saying x goes to 2, then when x approaches to 2, this whole function is going to approach us to 2 cubed minus 5 times 2 minus 1, which is 2 cube is 8, minus 10 minus 1, which is also 8 minus 11 is negative 3, right? This was not clear. I mean to say this is then. Right. Okay, so same thing for this one. Even for this one with the fraction, if you see first, if you see if there is any way I can cancel numerator and denominator, we have to do that first. If not, then just plug in this x value there and see if you can get the value. All right, so again, for this one, when x approaches to negative 3, then this whole thing approaches towards negative 3 over negative 3 plus 5, negative 3 plus 5. All right, so this is, on the top it's negative 3, bottom it's 2, right? And for this one as well, we have a square root. So when we have a square root, if you see this, if you see this property, when you see a square root or a root, then we can just take the limit of inside, and this square root is going to stay in there. All right, so then I can say just the limit of, this is also same as square root of, just take the limit of inside. Limit of x goes to 1 of f of x plus 4. So then from here, when x goes to 1, and I can say square root of 5 times 1 is 5 plus 4 is equals to square root of 9, which is 3. All right. Okay, now the next one is, okay, what about the limit of something like this? Okay, so I said that when you have to take the limit, I can just say, I said that with the fraction something like this, I have to cancel the numerator and denominator if I can cancel. All right, so we can do that. Well, we know a square minus b square. If I'm subtracting 2 square, then there is a formula where I can say this is a plus b times a minus b, right? So similarly, on the top we have x square, y square is also 2 square, right? So this I can say x plus 4 and x plus 2. And x minus 2, right? So first, yeah, like I said, first on the fraction, if you can, you have to try to cancel, right? So limit of x goes to 2, x plus 2 times x minus 2 over x minus 2. So I have x minus 2 and x minus 2. So I can cancel these two. So that means I just have x plus 2 right now. If limit x goes to 2, then this whole thing approaches towards x is 2. So 2 plus 2 is 4. Right. Similarly for this one, I have to try to cancel numerator and denominator. So x square minus 1 or x square minus 1 square. So that means I have a 2 square with the minus in the middle here as well. So this one I can also write limit of x goes to 1 x plus 1. On the bottom, I get x plus 1 and x minus 1, right? Using this property, right? Because 1 is also 1 square. So now I can cancel this whole thing, x plus 1, x plus 1. Then I get on the top, I just have 1, right? So when x goes to 1, then this one goes to 1 over 1 minus 1 over 0. All right, so now this kind of a case, when you divide anything by 0, it's always undefined. All right. Okay. Now, let me see if I have anything to cover. Oh, yes. One more thing. Okay, so let's say if I have, if I want to take a limit of f of x goes to something, let's just say something c. The limit of x goes to c of f of x over g of x. Let's say this one, for example, let's say the limit on the top goes to 0 and limit on the bottom also goes to 0. So again, this kind of thing, 0 divided by 0 is not 0. All right, this is not true. This is actually undefined. This doesn't exist. Okay. So yeah, this is this chapter is basically the introduction of limit. And the exam, obviously you need to know all of these things because you will see these kind of problems. So basically whatever I discussed today here, you will see most of it in the exam for sure. Because the exam is, I think the exam, first exam is this coming Wednesday. I will also send out the review to everyone. Send out the review to everyone. Maybe this weekend. I don't know, Saturday, Sunday. Maybe Saturday or Sunday. Or maybe Friday. I don't know. I think maybe Saturday or Sunday. I'll do that. All right. So yeah, go ahead and do the homework, the Pearson homework on time. I'll see you in the next lecture. All right. Thank you.